All right, here's example 4.1 from PreCalculus OpenStax. In this example, you're asked which of the following equations, functions, I guess, are not exponential functions. And as your book describes down here in the solutions, G and J are not. And it gives you the reason why. Basically, in G here, it's because the base is a variable, not a number. Another reason it's not is because the exponent up here is a constant, is a number, not a variable. So G is not, and J is also not. The logic here is kind of by definition, when we're talking about an exponential function, the base has to be a positive number not equal to 1. And -2 is not that. So these guys aren't. But what I think is more interesting is why these other two are, or specifically why F is. For H, it's fairly obvious why it is, or I don't know, it's more obvious, I guess. Playing the role of A is a 1, and playing the role of B is 1/3, because I don't need those parentheses there. And okay, these fit our criteria for A and B, and now I have A times B to the x power. It looks good. But this one here, it's a little bit harder to see what A and B are equal to. In fact, you have to do some pretty complex algebra to show that this really is an exponential function. So I figured I'd do it because I thought it was interesting. So the first thing you need to know is that this guy right here is equal to 4 raised up to the 3rd power raised up to the x minus 2 power. So when you have an exponent raised up to another exponent, you can multiply together those two exponents right there. And so if I started out with this over here, I could take the 3 and multiply it by the x minus 2 to get this. And if this equals this, then this must equal this. And the advantage of this form is 4 to the 3rd power. 4 times 4 times 4 is 64. So really, what is given to me here is 64 to the x minus 2 power. But this still doesn't fit the form a times b to the x power. However, I could say that this is 64 to the x power times 64 to the -2 power. And the logic here is that if I'm multiplying together two things and they have the same base, I can add the exponents. And x plus -2 is x minus 2. So that gets me here. And now if you can make the realization of what 64 to the -2 power is, well, that's the same as 1 over 64 squared. So what I now have, I can rewrite this and figure out that A must be equal to 1 over 64 squared, which is equal to, I don't know, something. 512 maybe? Yeah, I don't know what that's equal to. I won't pretend I do. Definitely not 512. Some number, and B is equal to 64. And so here's the value of A and the value of B that show that this is an exponential function. Your book didn't go through all that in the explanation here. I guess they don't really have to. But I think it's kind of interesting to see why. So if you were curious why f here is in fact an exponential function, that's why.